We're going to continue with examples of adding fractions with different denominators, but I'm going to use what is called the jealousy method for adding and subtracting fractions. I credit this to Paul McGuire, a teacher in San Diego. And if you want to see his videos from the 1980s, you can just search the word jealousy method on YouTube and you'll find it. So here's an example, 9/20 plus 5/18. Now, before we go over the jealousy method, let's just use one of the methods I've gone over so far, where we just have to find the least common denominator between 20 and 18. And I'm going to do that using the method where I put both of them sort of in this upside down division thing. 2 goes into both numbers. And there, nothing else goes into 9 and 10. So the least common denominator is just 18 times 10. So I know if I multiply the 18 times 10, I'll get the 180. Or, because it's the same thing as 9 times 20, so I actually need to do by 20 times 9 over 9, and to get 180 so that I have a common denominator. So that's going to give you 81 80ths plus 50 180ths, right? So that's 131 180ths. Now, of course, the next step is to see if this can be reduced. So you could do that by prime factorization, or you could just one at a time see if 2 goes into both numbers. Does 3 go into both numbers? No. Does 5 go into both numbers? No. Does 7 go into both numbers? No. Let's see, does 11 go into both numbers? No. And does 13? No, basically no. So this is reduced after you go through those steps. Now we're going to do the same problem using what I'm going to call the jealousy method. And to do the jealousy method, remember the original problem was 9/20 plus 5/18. But what I'm going to do is factor the denominators. So remember, these are the denominators of the original problem, 20 and 18. So I want to factor those. I don't factor the numerators. So you write the numerators down, but we factor the denominators. So 20, prime factor it. 2 times 2 times 5. And actually, you want to leave a little bit more space. I didn't leave much space here. So let's do that. You want to write big, long fractions. All right. And we're also going to factor 18. Prime factor it is 2 times 3 times 3. All right, here's the idea. Each denominator wants to have at least the same factors as the other denominators. Right? In other words, it's jealous, if anything, the other denominator has that it doesn't already have. So we look at the first denominator, 2, 2, and 5, and it looks over at the other denominator and it says, well, it's got a 2. Cool, I already have a 2. But it has 2 3s, and I don't have any, so I want 2 3s. So it's jealous. It takes on 2 3s, but whatever is multiplied in the denominator of a fraction also needs to be multiplied in the numerator. Now, once you do that, the least common denominator is what you have in this denominator, this first denominator. The guy who's jealous looks over, gets what it wants. That will now be the least common denominator. So for the other denominator, I have to make sure it has all the same factors. All right, so it has a 2, it has a 3, and a 3. It needs all 5 factors. It's missing a 2 and a 5. So I multiply its denominator and numerator by the 2 and 5, and now they all have the same denominator. Hence the jealousy method. Neither of them are jealous anymore because they have exactly the same denominator. All right, so now what do? We have to multiply those numerators together, or if you want, you could just leave it in factored form in case something might cancel at the end. In this particular problem, since I did it previously, I know I'm going to end up not being able to reduce it. So I'm going to go ahead and write 180. But if you'd like to keep it factored, that also works. It's just at the end of the problem you have to multiply the 2, the 2, the 5, the 3, and the 3. Now let's do the numerator of each fraction. I'm going to have 9 times 9, that's 81. I'm going to have 5 times 10, that's 50. And I get exactly the same answer as I got in my using the previous method up above. Okay, now for two fractions, I think the method I have up at the top is pretty easy because it's easy to just put it with this division sign and there's not a lot of prime factoring going on. But this is really a nice method, especially when you have more than two fractions. So let's do an example with three fractions. How about 5/6 plus 3/4 plus 8/15? Right, so what I want to do is start out by prime factoring the denominators, not the numerators, and I want to write big fraction bars. So 5 over 2 times 3 plus 3 over 2 times 2 plus 8 over 3 times 5. All right, so we just start with the leftmost fraction, looks over at each denominator, right? The denominator of the first fraction looks over and it wants at least the same thing that every other denominator has. So all it has is 1, 2, and 1, 3. Looks over to the first fraction. Hey, that guy's got 2 2's. That's like saying, hey, that guy's got 2 cars. I only have 1. I want 1 too. So it wants a 2 to keep up with his next door neighbor over here. All right. It also looks over at the, what's like the third house down the block? It has a 3 and a 5. Hey, it's got a 3. It doesn't have a 5. Okay, so imagine that's something it wants, like a blender. All right, so this guy also wants to have a 5. So now notice this in this first fraction, the denominator, it has at least the same factors in the other two fractions, denominators. So this now is the least common denominator right here. Okay, that is the least common denominator. I just have to make sure each of the other denominators has the same 4 of those. So let's see. This second fraction has 2 2's, right? Okay, but so it needs a 3 and the 5. So it needs a 3 and a 5. Now if you want, you could write times 15. Doesn't really matter if you put 3 times 5 or you write 15. And now the last fraction, it needs all 4 factors, so it needs, what, 2 of the 2's? And so there we are. So keep in mind, you could have written, instead of 2 times 2, 4 in the numerator and 4 in the denominator. That's up to you. Now look, they all have a common denominator. The denominator of all of these is 2 times 3 times 2 times 5. So now, we don't want to cancel because then we're back to square one. I'm going to write one big fraction. All right. I know the denominator now is going to be 2 times 3 times 2 times 5. You could multiply those all out, or you can leave it factored. Let's multiply it. That's 10 times 6, or 60. Now, in the numerators, before you add, you're going to have to multiply what's in the numerator of each fraction. But then we're going to add. So I'm going to write one big fraction bar here. So on the top here I have 10 times 5. That's 50 for the numerator of the first fraction, plus in the second fraction I've got 9 times 5. That's 45. And in the third fraction I've got 8 times 4. That's 32. So you could have written 50 60ths plus 45 60ths plus 32 60ths. But what I did is I just wrote one big fraction bar so I could only have to write the 60 down once. And then we need to add all those numbers in the numerator. So we can go over on the side here. You can just add 50, 45, and 32. And that's 127. Okay? So I've got 127 60ths. Now the next thing to do is to see if you can reduce it. And so let's see, 2 doesn't go into both numbers, 3 doesn't go into both numbers, 5 doesn't go into both numbers, 7 doesn't go into both numbers, and neither does 11. That's as high as I have to go. So this is reduced. So that's your answer. Or you could write it as a mixed number, by dividing 60 into 127. So that's 1, whoops, no, that goes in 2 times, doesn't it? 2 and 7/60. And that's it for the jealousy method. I'll do some more examples on the next video. Thanks, Paul.